Okay, good morning, everyone. Welcome to Fit 107 Software Quality and Testing again. This is a week 11 already, which we will talk about software security. It is the most important topic because let's say if you want to develop, let's say like a mobile banking system or the payment gateway system, that kind of thing, you want to ensure that all of the information from the customer are safe and secure. Right? So basically, right now, security is like one of the most important quality attributes so far. And for some companies, they treat them as a main requirement as well. It's not just like we develop something and discover the security issues later, but actually we need to integrate the security aspect from the beginning of the software development. Okay. Yeah, so I think for this lecture, we will go through one by one and what it is, okay? And before we go to the lecture of this week, I just want to remind everyone again that next week we will have an industry guest speaker from Aquasec, okay? So it is one of the top company about software security, and he will talk about how can we bridge the gap between the DevOps and the security. Okay. DevOps, we use like a CI/CD before. Okay, we develop the code, automatically run the CI and deploy. Okay, through the CI/CD pipeline. But I think the key question is that how can we integrate the security aspect into the DevOps pipeline? Okay, so I think this is something that is used nowadays in practice, and I highly recommend everyone to attend. This is to welcome them as well, and also to show the appreciation. Okay. Yeah, please consider attending. The weather is weird. Okay, so today, the learning outcome, we will talk by the end of this session, you will learn what is software security, and when software security has an issue, such kind of thing is called vulnerabilities, right? So we will talk about that briefly as well. We only focus on the most common type, like SQL injection, buffer overflow, and then let's say that if someone found such kind of vulnerability issues, what people do, right? So they're going to report to the CVE, CWE, what is the NVD? We will talk about that as well. And how can we develop the quality assurance strategy about the software security as well. What is a threat modeling, threat driven design? What is how can we identify the security requirement? How can we decide the security mechanism and incorporate into the software design, right? And yeah, we also talk about some techniques as well to detect security issues like static analysis, dynamic analysis, and the fuzzing. Okay. So when we talk about software security, we often look into three perspectives here. The first one is the confidentiality. The second one is the integrity and the availability. Okay, so what does it mean? Confidentiality, it means like, let's say if you want to store a password, you don't want someone to steal that kind of username and a password, right? And the integrity, we talk about the data encryption. How can we ensure that the data can be accessed by the some certain of the people, that kind of thing. Okay, integrity. And then data availability means that let's say if the system got the DDoS attack, like a denial of service, like let's say you have a system and then suddenly you got like a 1,000 million requests at the same time, and then the system is failure, it's not available anymore. Then the key question is that how can we ensure that the system is still available when we have that kind of attack, right? So for this one, we normally talk about like a discovery no sorry data recovery issues, and like a backup system, that kind of thing. Okay. Yeah. So this is like the things, the situation when what happened when some of these security properties are not met, right? Like For example, the first one, confidentiality. Okay. Let's say, yeah, as I mentioned before, an attacker, stole the personal information, credit card number, corporate secrets, that kind of thing. So it breaks the confidentiality, the data breaches as well. You have seen such kind of these issues in the news before as well. So yeah, that's why we need to be careful about this one, confidentiality. In terms of the integrity, right? We are talking about when we store the data, can the data be changed or not? Okay, that's why there are lots of attacks like malware, spyware. They just want to let's think about what is that? Let's say malware application and in Android. Okay, you like attacker normally develop like a fake application, inject the malware into the application. When the end users install it, okay, then the malware app will modify the data, steal the information in the mobile app, that kind of thing, monitor that, blah blah blah. Okay, so it lacks of the data integrity, the security issue, this one. Okay, so whenever we store the data, it should not be modified at all. Okay, that's the data integrity. That's why we have the blockchain. Okay, and data availability means that when the software, the system is hanged, is crashed, it got the denial of service, that kind of thing, DDoS attack, then it becomes unavailable. So how can we address that kind of issue as well? Okay. And then, yeah, when we talk about the software security, then the key question is that how is it different from the functionality correctness that we talked at the beginning of the unit, right? So when we talk about the functionality correctness, it means that we want to develop the software to meet the end user need. Okay, that's what we want to do. But when the software is well developed, it is of high quality, it doesn't mean that it is secure. So that's why we want to make sure that the software that we develop should avoid such kind of undesired behavior as well. Okay, so that means we need to consider these three security properties: confidentiality, integrity, and the availability. Okay, and how is it different from the computer security, right? So when we talk about the computer security, we just talk about the whole system, not just the piece of software. So it is much broader. The term is much broader, and they talk about network security, the system security, the firewall, that kind of thing. The system level is more than just software. Okay, software. When we talk about the software security, we only focus on the code. Okay, but the piece of software may connect to, maybe deploy in the cloud, maybe appear in one of the network in an organization, that kind of thing. But the whole system is called computer security, is beyond the software security. Okay. That means when people who maintain the computer security issues, they often be like a system and a network admin, cyber security analyst, and the engineers. It's beyond the piece of software. But if we are focusing on the piece of software that we develop, we the practitioners who look after the software security issues should be software developers, software engineers, QA, tester, security analyst, that kind of thing. All right. Okay. So why software security is important, right? So let's say, as I mentioned before, if the computer security, the whole system is perfect, right? But it doesn't mean that the software is secure. Attacker can still access the system, into the system, that kind of thing. So they can steal the information anyway. That's why we need to look at the security aspect at the system level and the software level as well. Okay. And when we talk about the issues about the issues that are related to the software security is called software vulnerability. All right, it means that an exploitable software defect with security relevant consequences. Okay. For example, buffer overflow, overread, overwrite, improper input validation, and unrestricted file upload, right? Unrestricted file upload. What does it mean? Let's say this is a image sharing system in the cloud, and then you just upload an image that is uh, embedded with a malware or spyware or whatever in order to hack the image server, the server, that kind of thing. That's called unrestricted file upload. Okay. So, but when we talk about the software security issues, right, it's not just only the implementation, but it can come from the design as well. If we don't design to ensure that the security aspects that is met at the beginning, that becomes lots of issues at the end, right, during the implementation. Yeah. And yeah, so security can be ensured by eliminating bugs and design flaws or making them harder to exploit. So that's why we need to think about how can we design the system to ensure that it is harder to be hacked, it is harder to be exploited as well. So we're going to talk about that in this lecture. Okay. So the first type of the software vulnerability, this is a commonly known one. Okay, I will get a pen a little bit. This one is called SQL injection. I'm sure that some of you may attend the database unit before as well. So I'm gonna talk about like what does it mean. Okay, SQL is one of the database system, and this is a SQL command. Okay, this is an SQL command. And what's wrong, right? Like let's say if this piece of code, we have a method get request string to this username, and then because we want to get this username, okay, we have this variable to store the username. We want to select the users, okay. We need to craft an SQL command first. So we say select star from users. This is a users table where the column name, the username, equal to this variable username. Is that right? Okay. So what's wrong with this one, right? Let's say if we input the username as this one, John, or 1 = 1, so the where clause is always true. It means that where username equal to John, okay, username equal to John, or 1 = 1, so it returns true for this boolean predicate, right? And it means that all record in the users table will be returned. This is one way to, let's say, if you want to hack the some telecompany system, okay, you want to get access all of the customer information, 15 million people or whatever. If they don't properly handle the SQL command like this, you can probably access the whole 15 million customer record, right, by just use the SQL injection to attack the system. That's one way, okay. And what if you are, let's say, you want to do something even worse, right? To make the matter worse, you want to delete the whole data, all right? So you can say, you can do it as well. Where username equal to John, okay, that becomes true already, and drop table users. So basically, you want to drop the whole table. Then, if this is an issue, what's wrong? The data availability becomes an issue, right? That's the one of the security aspect, security property. So this one is not met at all. No, sorry, that security property is not met because the whole data is deleted already, right? Okay, so that's how if you want to delete the whole database, okay, you can try with this one, all right. And let's say if you want, it's not just only look at how many users in the table or drop the users in the table, right? Let's say that's just only the user. Let's say this is a banking information. You want to extract like how much money that each person has, then you can even use like a union statement, okay, to join the table from the other table, yeah, and then you can extract the information from the whole database as well. That's very easy. Was that fun? Yeah. All right. So the next one is a buffer overflow. This is commonly happen in the C and the C++ language. All right. So it means that it often happens when a large piece of data is written in a small buffer in memory, right? So it overrides the memory beyond the buffer. Let's say this is a buffer. Okay. This is a, let's say if we want to write the A, okay. No, yeah, this is a, the buffer is how many? 1, 2, 3, 4, 5, 6, 7, 8. This is a 8 byte, okay, 8 byte. Yeah, but you input the data as a 10 byte, okay, 10 byte. Yeah, so instead of just only the excessive, right, you put the E and the 0 as well into the system, so you can what happened is that you can get like a shell access to the system, or you can inject a piece of code into the memory and execute it as well. Let's say if this is a password, okay, excessive, this is a password, and then you run the next one, rm slash rm dash rf and the slash, that kind of thing. Okay, so what happened is that the whole system is removed, right? It is deleted. Yeah, that's an example. Okay, so that's a buffer overflow, how attackers attack the system. Yeah. Because this is more like a towards C or C++, I'm gonna skip that one. Okay, but right now it's not just only the what happened to the developers, right? We use ChatGPT every day, and then the key question is that whether ChatGPT can still generate the secure code or not, right? So I'm gonna try with the generative AI here. Okay, let's generate a Python program that receives an email address as input and pass it to a shell program. So basically the ChatGPT generate some output, right? Some recommendations, some response here. But then what happened is that let's take a look whether it is correct or not, right? Input, take the email address and then use the sub process to run the shell, run in the shell. Yeah, that's also right. Okay, but let's take a look whether it is capable to detect any vulnerability or not, right? So I ask, is this free of vulnerabilities? Okay, so they said the code I provide is relatively simple and does not appear to have any obvious security vulnerabilities. Okay, it's not, right? But actually, in fact, it is. What happened if I input the email address as rm, okay, slash dash rf and remove like this, okay? So this is a command in the Linux, right? To remove, okay, recursively and force from the root directory. All right, so this one is called arbitrary code execution, CWE94. It means that the input, handling input in this manner allows a malicious adversary to execute arbitrary code by appending shell instruction to a fictitious email, right? So that means I just input this one instead of an email address, and then I can, the program will just execute this command easily. The whole system is gone in 1 second. All right. So ChatGPT still cannot detect the vulnerability at all. But what if I try again? Okay. Can you try to generate the program, okay, with the email input validation as well, right? Again, the system, what happened is that they still use this kind of command, and it means that we can still hack the system, right? So they said, note that this code is still subject to the injection attacks and access control issues. So blah, 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 blah. It should be properly sanitized. It means that ChatGPT knows, okay, now it is a little bit risky. The code is still risky, but it's still generated, right? Then what if I give another try? Okay, otherwise I will give up with the ChatGPT now. Okay, yeah, so let's regenerate the program with the email validation function. like this one, validate email in Python. Okay, because I know that the input should be sanitized first. This one, right? Handling input should be cleaned up. Otherwise, it will be it is prone to have an attack, right? So email address, take the input, validate the input first, whether it is like in the right format or not. Is that the email address format? And then if it is yes, then we can execute it. Otherwise, we just say invalid email address. So this is the right way to make sure that the code is here. Otherwise, the system is gone. Okay, make sense, everyone? Remember in the megamart.py, okay, we have like the interactive part that takes the input from the user. Why don't you try? Yeah. Input instead of email address, you try im-if and slash. I don't know what is that going to happen. All right. Yeah. Okay. Yeah. So next one. So normally when a good hacker is called white hat, okay, white hat hackers. If they are good, they know that they discover these other security issues. They normally report to the public domain. This one, right? So it's called CVE or Common Vulnerabilities and Exposure. So it is an international community-based effort that identifies and maintains a registry of the publicly known cybersecurity vulnerabilities. Okay, so that means you just go to access to this one, and there is one CVE record for each vulnerability. But what I mean is that this is a CVE number, and this is a year. For each year, there are lots of ID, and then but this ID just belong to one part of the system or that kind of thing, you know. But one system can have multiple CVE as well. Okay, and yeah, that's it. Okay, do you have any questions so far? All good? Yeah. So if you have any question, just type in the Zoom chat and then I will try to answer. All right. So it's beyond the CVE, right? CVE is just a database. It's like a bug tracking system, just a issue, a list of issues that is publicly known. It is publicly available, and CVE is maintained by this organization, MITRE, okay, corporation. It is funded by the U.S. Department of Homeland Security, Cybersecurity, and Infrastructure Security Agency, CISA, and the VMC, this one. Okay, so NVD, CVE is maintained by this organization. That's the key point. So it is looked after by the US, and they have lots of data analysis statistic as well. So they have this kind of dashboard, right? So they look at today how many CVE are newly received by the NVD, and what happened to last week, to this week, to this month, last month, and this year, that kind of thing. So as you can see that like a whole for 1 year, right? There are like over 6,000 cybersecurity issues. So that's why it is become an issue, right? You don't want the system to be hacked by the attackers. So we should try to prevent the system from the security issues as much as possible. CVE status count score distribution or whatever. So it shows the distribution as well from the severity level, whether like how many for the critical one, for the high one, for the medium and the low one, right? And as you can see, like critical and the high one, it looks like over half of the everything, or over half is more than half of the distribution, okay? And this is an example of the CVE record. And it's not just only the CVE. CVE just only lists the issues, but sometimes multiple issues belong to one, how can I say, one type, okay? They are the same thing, okay? It just affect from by many many part of the code. That's it. Okay. So the type normally we call CWE, this one, common weakness enumeration. So it is a community developed list of software and the hardware weakness type. We talk about type only. Okay. So it has an ID as well. One of them could be SQL injection. One of them could be something else as well. I'm going to show you this one. Okay. So if you access the system, it will tell you like this, whether it is one of the top CWE or not, top 25, this one or not, right? Like this one, CWE 121 stack-based buffer overflow. There are different types of the buffer overflow as well, but this is like the top category, the high level, and there are something else as well. Okay, these are the top 10 weakness in 2022. So, for example, out of bound write, out of bound read, use after free, improper input validation, cross-site scripting, or SQL injection as well, that kind of thing. OS command injection, this one, improper neutralization of the special element used in OS command. These are very common. People often use it. Okay. Yeah. These are the top 10. And then the key question is that how can we find the software security issues, right? So we can use like manual code inspection, manual code analysis, static analysis, or the dynamic analysis as well, or it's called fuzzing. Okay, yeah, fuzzing. So finding, let's say if you want to use the static analysis, how does it work? Static analysis, as I mentioned before as well, we can use to detect the bugs, or we can use to detect the security issues, and it is a technique to only analyze the source code without executing it. That's why it's called static. Okay, look at the code statically. We don't execute it at all. And one of the approach is to look at the control flow graph. Okay, whether the data flow is correct or not. Control flow graph, data flow graph, that kind of thing. And yeah, so you can learn a little bit more as well. How can we use the static analysis to detect the security issues, right? But again, if you can find it, good, that's good. But if you cannot find it, but it doesn't mean that it proves the absence of the bugs as well, right? As I mentioned before in the week 2, DISTA quote, right? They say that software testing only prove the presence of the bugs, but not their absence. Okay. So that's a static analysis. There are lots of tools as well, right? For example, SonarQube, Kubernetes, Fortify, and for Python, we can use like Bandit as well. So in the workshop this week, every student will have a chance to experiment with the Python static analysis tool to detect the security issues only. It's called Python Bandit. Okay. Yeah, and the step to use is very easy. Choose a static analysis tool, configure the tool, run the tool, review the report, and fix them. Repeat the process until all of the issues are resolved. Okay. What about the dynamic analysis, right? So it means this one becomes harder now. So we need test cases to run the program. It can find bugs and the vulnerability, and also agree the same one as a static analysis one. It cannot prove the absence of the bugs and the vulnerability as well. Okay, so the dynamic analysis, you need to execute the code, right? So you at least you need the code as a code instrumentation to collect information about how an application behaves when it is running. So for this one, when you look at the code, let's say this is a C code, right? And then when you run the dynamic analysis, probably you look at the binary file. And when you look at the binary file, you can detect such kind of memory leaks or the buffer overflow as well. Okay. That's why we use dynamic analysis or the fuzzing as well. Okay. So what is fuzzing? Fuzzing, it means it is a dynamic software testing used to identify bugs and the vulnerabilities at the highest level. Fuzzing means randomly generated test input. Nothing more than that. So easy. Okay. So what does it mean? You can read more about the fuzzing book as well. What does it mean? Okay. So let's say you have, let's say add here. All right. You have input variable A and B, and you have a fuzzer here that randomly generate the test input. Okay. It can be like 1, 2, 2, 3, 0, 0, or whatever. Just randomly generate. Okay. That's it. And then apply this kind of test input into as a test case to test this method. And then it will discover whether the program crash or not. So they don't know whether what is the outcome. Okay, they don't know what is the outcome, whether 1 and 2 becomes 3 or not. They don't care. Fuzzer doesn't know. They only care about whether the program is crashed or not. So in short, the purpose of the fuzzer means randomly generate the test input until the program is crashed. Make sense? Okay. They find the bugs when the program is crashed or hang. If they don't find it, if the program is not crashed, then it means that the fuzzer still cannot find it. Okay, that's it. And there are different types of the fuzzers as well, like a black box fuzzer, white box, gray box, and like a generation based and the mutation based types of the fuzzer. So this is like what we study in the research, right? Like more like a for PhD level, that kind of thing. So it's beyond the scope of the unit. So I'm gonna skip now. Okay. Yeah, because there are different types of the fuzzer. People find it is quite effective, right? That's why right now they are used at Google as well. They are used in Microsoft as well, because you don't need to use like human to design the test cases at all. You just use the machine to randomly generate the test input, right? And test until the program is crashed. That's it. Okay. So this is the system at Google. How does it work? Okay, let's take a look at this one. It's called Google OSS Fuzz project, right? The goal is to make sure that the open source software system are more secure and stable by using modern fuzzing techniques with scalable distribution execution. So they execute the fuzzers in the cloud, all right, in the cluster. First developer here, okay, write a fuzzer, config something, okay, contribute into the Google, this one, OSS fuzz, okay. And then, okay, this is the class, the fuzzer infrastructure at Google. So you create your own fuzzer, submit to this one. If they approve, they're gonna deploy to the cloud. Okay, deploy to the cloud, sync and build from the cloud build, this one, upload to the Google Cloud, this one bucket, and then each instance or VM virtual machine in the cloud, just download and fuzz it via the cluster fuzz system. So they're gonna randomly test here. So cluster fuzz is mean that, let's say this is at the Google, right? Google. There are so many machines, let's say thousand machine. And the 1,000 machine just use the fuzzer from this repo. Okay, use the fuzzer from this repo. This is a machine. Fuzz the system, OSS system. Probably it can be more, like let's say 100 system here. Think about Apache, web server, Mozilla Firefox, or Google Chrome, Android OS, that kind of thing. So they're gonna fuzz the open source software system here. Whenever the program is crashed, OS is crashed, that kind of thing, they're gonna create a bug report in the issue tracking system. Okay, that's it. That's how it works in the Google. All right. Yeah. So once the issue is created, then the developer is notified. Okay. All that. Yeah. But it's not just such kind of fuzzers, right? Or static analysis too, dynamic analysis. So they are more like a post hoc. It's like a after things. It means that At the beginning, you don't care about the security issues at all. And then later on, once you develop the code, you just run this kind of technique. It's more like detection rather than the prevention. If you want to prevent the security issue, it should come from the design phase. It should come from the requirement phase at the beginning, right? So that means the security should be integrated into the requirement phase from the beginning. And we should design the system to meet the security measures, that kind of thing. All right. So this is again similar to the shift left software testing, right? We want to shift the this kind of process into the early phase of the software development as much as possible. Okay, so yeah, so security by design, it means that security measures need to be involved from the early phase of the software development, as I mentioned, and requirement design, test, deploy, okay, the early phase, not the maintenance, not like after the deployment at all. And adversary is not a normal user. Misuse cases should be considered in addition to the use case. For example, what is the use case here? What a user should be able to do and the misuse, what a user should not be able to as well. So let's say, what I mean is that security by design, let's say if you want to design this is an application, you have the username here, you have a password input box here, and you have a button submit, right? When you design such kind of system, you need to think about, okay, with this UI, what user should do. That's why you need to come up with a regular expression to validate whether the email address is in the right format or not, right? Misuse, okay, what user should not do, what the user should not do, what they should not do here. We need to think about that. They should not input something else that are not they should not input this for example, no, what they should do, they should input email address, right, in the right format. What they should not do, they should not execute, like let's say OS command via the email address. They should not do the SQL injection to steal the database, run the database for the whole system, drop or modify, that kind of thing, right? So that's why that you need to think about what is the use case here and what is the misuse case as well, what they should not do, okay? Yeah. So, and what is a threat modeling? Threat modeling, it means that how much power does the attacker possibly have, right? And what they can do with it, what information they can get, and how realistic it is, okay? So when we talk about the design, we need to think about, how can we add the security measures into the system from the design at the beginning? We need to do the threat modeling. We need to do the risk analysis. So for each of the misuse case here, what is the risk, right? What is the risk of having an attack? Whether it is high, low, medium, that kind of thing. So we need to think critically. Otherwise, the system will not be secure at all, okay? Yeah. So threat modeling is like a simulation, all right? So we're gonna simulate the system. We're gonna model. Let's say if the system has a threat, what would happen? What would it be? How does it happen? And how risky it is, okay? That's why it's called threat modeling or threat-driven design. We're gonna design the system based on the potential threat here. And when we do the threat modeling, it means that we need to estimate the severity, whether it is like an extremely severe case or not, like this one. If it is a network only a user can access the system via the network, right? Is that a high or low risk, that kind of thing. And if a co-located user like this one, a user on the same computer as a normal user of the system, so the power is different, right, among the users. What I mean, okay, let me put this way again. This is a network. This is a network of the organization. And then this is a one machine. Let's say this is a machine number one. There are so many users, right? Users within the local machine here, or user from the outside, okay, or the user within the organization. Then the key question that you need to think about is that these kind of users may be an attacker. And then what is the level of the access that they can access the system, right? So whether this one, they can act like these people can access this or not, right? So you need to think about like what is the severity and what is the potential threat that can happen as well. A local people within the M1 machine, if they have access to this level, what they can do, what they cannot do, that kind of thing. Okay, that's a threat modeling and threat driven by design. So we design the security issues based on the potential threat category. Let's say if it is a network only attacker, we need to think about the authentication mechanism like a login system with the secure password policies. If we want to prevent the sniffing attackers, okay, so we need to think about the encrypting the message. Then the communication between the people should be encrypted, right? But the key question is that what kind of encryption and at what level that we are going to use as well. Okay, co-located attackers, we can use the multi-factor authentication to prevent such kind of threat as well. Okay. Yeah. So as I mentioned before, when we do the threat modeling, we need to do the risk analysis as well. And both of these will provide a kind of attack the system need to be secure against. Okay. So what should we, when you have one system and you have no idea what to do, you need to think about what is the potential threat to the system, right? And then once you decide such kind of threat, model the threat, who are the people who attack it, what kind of threat, at which level, how severe it is, then you can design the system to make sure it is secure against it. Okay, that's it. All right, but when we do the security by design, it should start from the requirement. Is that right? When we design the system, some of the typical security requirement can be these three. As I mentioned from the beginning of the lecture as well, that we should talk about the confidentiality, integrity, availability. This is like the three security properties. Okay, so that means this is an example. If we want to develop like healthcare system, we may say that customer health profile only known to be the account holder. Okay, so that's the confidentiality. It cannot be accessed by someone else at all. Integrity. The history of the medical services provided to the customer should be preserved and not damaged by unauthorized parties. Oh, that's one of the requirements, right? So it means that the data integrity should be extremely high. No one can access and modify it at all. Okay. Availability, customer must be able to access to its health profile 24/7. So if the system got DDoS and a DDoS attack, it still should be available to the to be accessed. Okay, yeah, to access the health profile, that kind of thing. Okay, make sense, everyone? And there are a few design mechanisms as well. Okay, these are the top three. For example, authentication, authorization, and the audit. Okay, I think everyone is familiar with this. Authentication is like we want to ensure that a user is actually who it says they are. Okay, yeah. So if I want to access the system should ensure that am the person who is with this name to access the system, not someone else at all. So that's why we use the two-factor authentication, right? To double check whether is that the right person. You have a if I have a username and a password from one of the from someone, right? I can access the system, but I may not be that person. So the system, the good system should have that kind of level as well, authentication to ensure that the user who log into the system is actually that person. Okay. Authorization, this is more about permission, right? We want to ensure that a user can only perform actions it is required to do. Myself, not the admin of the system, can I access the whole database of the university or not? Probably no. That's about the authorization level, right? Audit ensures that the system keeps enough information to tell whether a breach has happened or not, right? So we should have a log as well in the log record, right? Who access the system, when or whatever, they should have the whole history to detect and this to analyze later whether it is a breach or not. Okay. And there are a few design principles. Okay, I'm gonna go through one by one that we should adopt. Okay, first principle. The first principle: favor simplicity. Keep everything as simple as possible. We should go for this one. This is the first principle. Okay, so that means this is like intuitive already. The more complex the system, the higher the risk of flaws, right? So you can measure by the psychometric complexity or whatever, and then you if the system is more complex, right? Measure by the psychometric complexity, too many loops, too many condition if else, too many for loop, while loop, or whatever, then it becomes harder to maintain and it is prone to be attacked by the attackers as well. Okay. Yeah. And so flavor simplicity, keep everything as simple as possible, but what we should not do is to set a safe default setting, right? No, I'm sorry. I mean, whenever we decide the default setting, it should be safe as well. So that means we should not set the default setting like for the password. We should not say that this is a default password, right? No, we should not do like that. Or we should not have like a default key length of encryption. We should not have like a default password policy or whatever, that kind of thing, you know? So the default, when you want to set the default to some parameters, it should be carefully designed as well, whether is that the right value, the right variable that we should set the default, right? And for example, the password, we should not, okay? Yeah, that's an example, okay? Trust with number two, principle two, trust with reluctance helps preventing attack, right? So when we system normally take lots of input, how can we ensure that the input is valid, right? So that's why we need to have such kind of input data validation. We should build the trust with the reluctance as well to prevent the attacks, okay? Like email address validation, password validation, whether it is at meet the minimum requirement or not, that kind of thing. Okay. Yeah. And other things as well. Principle three, least privilege, right? The user should not have like admin permission by default, but they should have like the least privilege, okay, to the system. And whenever that user requires more permission, they need to send a request to the admin, to the board of the company, of the organization, or whatever to grant additional permission. Otherwise, the least privilege is the ideal approach. Okay, that's why it is one of the principle here. The fourth one, in-depth defense. Okay, what does it mean? So it means that we're going to use multiple layers of defense, don't rely on one defense or defense type. Okay, what does it mean? Let's say this is an organization again. Okay, the network, the whole system. Probably this network is one layer of defense already, and different organizations may have different branches, right? Like headquarters or whatever. So this is a whole organization. Each of the office have its own level of defense as well. Each within the office, you have multiple computers. So each of them have its own level of defense as well. So that means we should not just like have the organization level defense, but the defense should be at all level at all. Okay, should be at all level, like more than just a firewall, password encryption or everything. Okay, it should be every level. Okay. Yeah. So throughout the software development life cycle, right? That's the software design integrated the requirement no, sorry, integrated the security into the requirement. And now during the software development, how can we prevent the vulnerability issues as much as possible, right? So the first step here, we need to think about the data categorization according to its sensitivity. When we define the variables in the program, whether it is a username, the password or not, or it is just like a dumb variable, right? And then we need to develop the security requirement. We need to enforce the security and the correctness requirement using proper design mechanism. We start implementing, and then we need to test for the success as well. Test for the security issues and the correctness issues. This is how we integrate the security aspect throughout the software development lifecycle. All right. Okay, there are a few case studies as well. Okay. This is Optus data breach in 22 September of the 2022. What happened is that hackers access the record of the 2.5 million and the 9.7 million current and the former customer at Optus, right? And the customer that attackers get is like license, driver license, passport, credit card detail, and other highly sensitive information as well. Okay. And right now, the hackers are threatened with a $1 million ransom to be paid by Monero, which is one of the cryptocurrency platform. Do you get what does it mean? I will explain again. Myself, as a hacker, I hack into the Opta system. Okay. I get the 2.5 personal information. Okay. I probably send a message to Optus. Hey, can you pay me $1 million to the Monero? And then I will stop leaking the personal information. Okay. So that's what the hacker did. Okay. In the past. We take a look further, right? So what is a security flaws here? It means that there's a public facing API without authentication, which was not isolated from the core business processes as well. The open API facilitated access to very sensitive customer data. So that's about, what is that? We talk about three security properties. What is that? Do you remember? Confidentiality, integrity, and the availability, right? Confidentiality is this one. Let me see. Confidentiality, integrity. What is the integrity? Yeah, this is the confidentiality. This is the integrity, right? Confidentiality, it means that the data is very sensitive, but still they don't keep it confidential. So that's why it can be accessed via the open API here, okay? And the integrity, no, sorry. This is a confidential as well. Okay, back. Yeah, I think both of them, all of them is the confidential issues, okay? Because when they design the system, other users can access the data without the proper authentication. So the data is not confidential at all. Sensitive data is also leaked. Okay, that's a confidential issue. Yeah, that kind of thing. That's right. That's why it violate. While if we look back to the design principles, right, it violates these two principles: trust with reluctance and the in-depth defense. Okay, that's the Optus data breach. But what about Medibank? It's like 1 month after. Okay, hackers stolen published sensitive private information of over 9.7 customer on dark web. Okay, so again, hackers stole lots of customer information, and this is something that we should not let that happen at all. Okay, I'm aware of the time. This is an example of the case study, right? Like Optus data breach, Medibank data breach. And when most of the information are leaked, it impacts the not just only the budget of the company, but also the reputation as well. Let's say if you want health insurance, will you use Medibank or not, right? It raises a lot of concerns. So that's why they, as a company, let's say if you work at the Medibank, you need to develop security measures, make sure that the software is secure, the system is secure, it is prevent from attacks, and you want to build trust and the confidence with the customer. That's why software security issues is so important. Okay. All right. That's all for today. And if you have any questions, please feel free to ask, or you can post in the ED forum as well. Otherwise, have a good day, everyone. See you in the studio. Yeah. Bye bye. So regarding the and there's a one question about the assignment 4 as well. You can ask during the studio as well due to the limited budget right now from the faculty. I'm not quite sure whether we can offer like an additional consultation hours or not. But I would say that if you have any question, post on the ED forum. I will try to answer as much as possible. Okay. Yeah. Thank you so much, everyone. Bye bye.